Hello everyone. Today we are in the chapter 7 of 8086 microprocessor. Our discussion topics is today logic, shift and rotate instructions. First of all, logical instructions. The logic boolean instructions are performed in operands as bitwise operators. Like as AND, OR and XOR instructions are written as AND then destination and source, OR is same and XOR is again same. Now, there are some effect of flags that we have already discussed. Here are some rules that you need to go through. Every time remember that memory to memory operations are not allowed. Uses of AND, OR and XOR are given here. Those can modify bits, those can construct source pattern, and only desired destination bits are modified. First one is the AND instruction. AND instruction is used to add the source and the destination section in AND instruction. OR is also the same. In OR section, we do the addition task, and in AND section, we do the multiplication task. That's how we write the code of XOR. Here is the source and destination, and this is the opcode. In this section, CMP denotes the compare section. If the value of Cx is 0, then the result of compare is OK. If not, then it is not OK. Not instruction. Here in AX we have a value, suppose it's 1, and if we write not AX, then the 1 will turn into a 0 with the not instruction. Now the test instruction. The test instruction performs an operation of destination with the source but doesn't change the destination constants. That means in this section this test will work with the destination and also with the source, but it does not change the destination constant. Now we are in the shift and rotate instructions. Here first we need to call the opcode, then destination, and then the value. First we need to know about shift left instruction, which is denoted as SHL. SHL shifts the bit into the destination to the left. That means the destination bit will shift it to the left section. Now we have SAL, which is denoted as shift arithmetic left. That means here we have an index value and here we have a CF. In this section we need to shift from arithmetic values from right hand to the left hand. First of all, we add a 0 in this position and then shift one by one from 0 to 15, and lastly we'll move the value to the CF section. This one is known as SAL, or shift arithmetic left section. By this SAL we can easily perform the multiplication by shifting. In this section you can see that a left shift on a binary number is multiplied by 2. Suppose AL contains of 5 in binary, which is as 0000 and lastly 101, which is denoted as 5. After left shifting, the value will be generated as, here we have put a 0 on the right side, and then the value is generated as 1010, which is 10. So that's why the value was 5 and now it is the 10, which is twice of 5. That is how by left shifting we can easily multiply values by 2. That's why a left shift on binary number multiplies by 2. Now we are in the right shift instruction. Here the SHR performs the right shift on destination of operands. That means it will add a 0 value to the left section, and from 15 it will move, and lastly the 0th index will be moved to the CF section. By here we can be introduced to the SAR, which is shift arithmetic right. Here by shift arithmetic right we can have this output as from this 15 to 14, 13, and lastly the 0 value will be moved to the CF section. That is how we will generate a dividing section. By left shifting in binary section we can multiply by 2, and by right shifting we can divide it by 2. As here we have BL, which is contains 101, that means which value is 5, and then after right shifting to the BL we have value 10. This one is removed from here and which is removed to the CF. That is how we get the value 10, which is 2, which is the division of 5 by 2. That is how we can say that by right shifting we can divide the binary value by 2, and the left shifting can multiply value by 2. Now the most important topics, which is rotate left, is known as ROL. In this section we can see that the index number 15 is moved to the index number 0, and then the 0th value is moved to the 1, and again, and lastly the value is shifted to the CF section. This condition is known as rotate left. Now rotate right, which is denoted as ROR. In this section the index value 0 is moved to the value index 15, and then it will move to the right, and lastly the 0th value is moved to the CF section. That is how the rotate right or ROR works. Now we have rotate carry left. In this section we have the carry flag in the middle point. In this section RCL shift bit of destination to the left, the MSB is shifted into the CF section. Here the MSB is shifted from 15 to the CF section, and the previous value of CF is shifted into the rightmost section, which is the 0th index, and every bit is shifted to the left section. That's the reason it is called the rotate carry left. So this is the diagram of rotate carry right. So first of all we need to move the value of index 0, which is on the right side, to the carry flag, and then the value of carry flag is moved to the index 15, and every element is moved from left to right. That is why it is called as rotate carry right section. Here are some examples. Those examples are smallly important for your examinations. You can easily do these mathematical terms in your home. No more today. Thank you.